In this clip, I'll discuss 8 design guidelines in current use. Each guideline differs from the others in scope or depth of advice and carries a different assumption about how people learn from multimedia. A few of these guidelines prescribe design activities, but most are non-specific descriptions. Why are there so many? Because design means different things to different people. The 8 design guidelines are, if you look at this slide, whatever works, design by type, favorite method, favorite feature, balanced input, maximum input, cognitive load, and structured sound functions. So that's 8 design guidelines. Let's look at each one separately. First one, whatever works, as a guideline for designing multimedia. Whatever works is based on the intuition of the developer. That is to say, the preferences, predispositions, and experiences of the designer. Under certain conditions, whatever works can serve to make the unfamiliar familiar. In other situations, they can aid exploration, helping the user to identify questions, select constructs, or develop measures. A fundamental problem with whatever works advice, however, is that it can only provide simplistic methods of combining sound and visual events that describe student interactions with the technology as a function of the playback devices on the system, instead of how learners should manage the incoming visual and auditory sensations. The Whatever Works guideline usually reflects a common problem for learners, either an outdated bottleneck expectation of student attention, a randomly cued, usually cosmetic music or sound effect, or redundant spoken prompt played at the same time as a photo or video shown of the event, plus running text at the event from a character generator. The continuous oral reporting of a locale or a particular point of view without contextual data. Random audio feedback that gives away the entire answer. Number 2, design by type. The design by type guideline for multimedia learning ascribes 4 instructional categories to the computer programs: tutorial, drill and practice, simulation, and game. Teachers using any of these programs could learn to design materials for their students or let them take an active role in the design of their own materials. Contemporary instructional software, or courseware, frequently combines these category types into a suite of programs. We will concern ourselves in this course with 2 of these, tutorials and drills. Let's look at tutorials first. A tutorial computer program purports to help users to learn in a variety of subjects. Tutorial programs are designed with the first 5 events of instruction as follows. Number 1, gain the attention. The important aspects of the computer program is the first event. Attention is critical to learning. Without it, no learning can occur. Number 2, inform the user of the objectives in the program. This is the second event of instruction. A learning objective is a statement for users in an ABCD format. That is to say, the audience, the behavior, the condition, and the degree. Communicating objectives takes little time and can help the user to stay on track. Number 3, show users the relationship between what they will be learning in the computer program or website and what they already know to this point. This step also lends relevance to the learning process. Number 4, present some material. This is the 4th of 9 events of instruction. 2 basic choices can be used for presenting material in computer-assisted instruction or website, either direct or constructivist. The aim in direct instruction in CAI is to transmit some skill or knowledge in a structured way, monitor their performance, and then provide some feedback. The aim in constructivism, in CAI or website, on the other hand, is only to guide the user as they explore, then facilitate the learning process as they collaborate and use the resources. Then they generate their own knowledge. 5, provide guidance in the computer program. This is the 5th event of instruction. This type of guidance depends on the choice of instructional method adopted. The direct instruction method will have plenty of guidance and more support. The constructive method will have less guidance, less support. A drill and practice program assumes that students already have seen or heard something about the concept or principle involved. So our business then is to look at 4, 5, 6, 7, 8, 9 of the drill of the events of instruction. Number 4, present some material. It's the 4th of the 9 events. Number 5, provide guidance in the computer program or website. Number 6, elicit evidence of user cognition and performance through fault-free questions or ungraded responses. This type of evidence collected will again depend on the instructional method that you adopt. Direct instruction would have a product developed to exact specifications and matched to objectives, such as a test following a podcast lecture, observation data of a complex skill performed to mastery, or multiple choice data after practicing a drill. Constructivist instruction, however, would have an electronic portfolio, for example, of original products developed by the user with little or no assistance, such as an original lecture uploaded into voice over IP technology and presented to peers for their criticism, or even the user's thoughts and feelings recorded, spoken or written, in a diary about the learning process. Number 7, provide feedback. Not all practice in computer-assisted instruction requires feedback. If the expectation is that the user will rehearse some knowledge of or a skill that was previously introduced, then feedback is required in the CAI or website. If, however, the expectation is that the user will experience some new knowledge or explore a new skill for the first time, then feedback is not required in the computer program or website. Number 8. Assessing cognition and performance through assessment. In direct instruction CAI, cognition and performance would be assessed usually by a written test or the development of a product to a specification or standard. The measure of success would be the same for all users. In constructivist CAI or website, cognition and performance could be assessed by observation, peer assessment or self-assessment, and peer assessment and self-assessment, or product portfolios against a rubric or a checklist. The measure of success could be different for each user. Enhancing retention through transfer tasks is the 9th event of instruction. Presenting users with a variety of tasks that are related to what they have already learned can help them to transfer original learning to the new context. This is called task endogeneity. Or low road and high road transfer happens when the conditions in the new context are sufficiently similar to the original learning context to trigger well-developed semi-automatic responses. High road transfer requires mindful abstraction of the original learning context or application and a deliberate search for connections. I have to warn you that these are difficult. They are long-term objectives to get transfer, knowledge transfer, and that's been the same in the research since 1901 when Thorndike was trying that with kids. Okay. Number 3, favorite feature. Since the 1940s, instructional designers chose technologies for their features. Comparing one technology or feature of a technology with another, the favorite feature guideline persisted with early adopters' continued use of certain software and certain features in software to the exclusion of other features. Guidelines were developed that subsequently helped to popularize the view that learning from multimedia simply meant selecting an appropriate feature or plug-in technology to deliver the instruction. Favorite feature research usually compares computer or web-based material presented in a lab with an instructor-based presentation in a classroom, or distance education technology against classroom instruction technology. Favorite feature research is likely to continue as long as evolving hardware and software permits designers and users adaptive and non-linear interactions and greater differentiation of visual events and sound. Number 4, favorite method. Advocates of the favorite method guideline of multimedia design are usually critics of the favorite feature guideline. This favorite method guideline is based on the most popular teaching method of the time. One of the most favorite teaching methods in multimedia is called the events of instruction. A central claim of the favorite method guideline was to implement a particular teaching method into a computer program or website using some of the 9 events of instruction. Number 5, balance the input. According to this guideline, multimedia should be a balance of logogens and imagens. Logogens are words that are spoken or they're in on-screen text, and imagens are pictures or graphics. Based on Pavio's dual coding theory, which distinguishes between a language-like system of verbal codes in memory and a separate nonverbal system of spatial codes in memory, separate memories. The implication is that users will learn better when the instructional material does not require them to split their attention between multiple sources of mutually referring information. A balanced input is achieved when multimedia generalizes logogens and imagens in the user's mind. The words, spoken or in text, get weeded out and offloaded into narration for processing separately, because users learn better when the verbal information is presented in auditory as speech rather than visually as on-screen text. Richard Mayer is the main proponent of Balance the Input guideline. Mayer set out 10 principles of multimedia learning, which we're going to look at right now, essentially descriptions of how undergraduate psychology students learn from non-curricular materials. So let's look at those 10 now. Number 1, multimedia principle. Multimedia principle states that adults learn better from words and pictures than from words alone. Number 2, the contiguity principle. Adults learn better when corresponding words and pictures are presented near rather than far from each other in time or on the screen. Coherence principle is number 3. Adults learn better when extraneous words, pictures, and sounds are excluded rather than included. Number 4, the modality principle states that adults learn better from words and pictures when words are spoken rather than printed. Number 5, the redundancy principle. Adults learn better from animation and narration than from animation, narration, and on-screen text. Number 6, the personalization principle. Adults learn better when words are presented in a conversational style rather than a formal style. Number 7, the voice principle. Adults learn better when words are spoken in a non-accented human voice than in a machine voice or accented voice. Number 8, the signaling principle. Adults learn better when the voice signals important words rather than when there are no signals. Number 9, the interactivity principle. Adults learn better when they can control the pace of the presentation than when they receive continuous presentation. Number 10, pre-training principle. Adults learn better when they receive pre-training on each component rather than no pre-training. Now we'll move to the next guideline, which is number 6. We call that maximum impact. The maximum impact guideline is based on a contemporary theory of human working memory of sensory regulation. This method has been applied to a cognitive theory view of multimedia learning, with the aim of dispensing separate sensations for auditory and visual memory systems. Like the balanced input guideline for multimedia, the qualities or quantities of sound and visuals of the maximum impact guideline must be about the same to reduce the probability of diverting attention in the novice's working memory. The 7th guideline, design guideline, is called the cognitive load first. The cognitive load guideline states simply never overload or underload the user based on cognitive load theory. Cognitive load theory distinguishes between 3 types of cognitive load in working memory: intrinsic, germane, and extraneous. Intrinsic load refers to the number of information elements the user needs to hold in working memory simultaneously to comprehend information. Element interactivity is intrinsic to the material being learned and cannot be altered by instructional manipulation. Only a simpler learning task that omits some interacting elements would reduce the type of load. The omission of essential interacting elements would compromise the sophisticated understanding, but may be unavoidable in very complex, high-element interactivity tasks. Extraneous load is that which is increased in a learning environment or instructional methods that require users to engage in activities not required for a new schema, construction, or automation. Extraneous cognitive load is primarily important when intrinsic cognitive load is high, because the 2 forms of cognitive load are additive. If intrinsic cognitive load is low, then levels of extraneous cognitive load may be less important because total cognitive load may exceed working memory capacity. As a consequence, instructional designs intended to reduce cognitive load are primarily effective when element interactivity is high. When element interactivity is low, designs intended to reduce the load on working memory have little or no effect. The designer who aims to keep from overloading or underloading the user with sensations may follow the cognitive load guideline. Whereas extraneous load interferes with learning, germane cognitive load enhances learning. Instead of working memory resources being used to engage in search, for example, as occurs when dealing with extraneous cognitive load, germane cognitive load results in those resources being devoted to schema acquisition and automation. Note that increases in effort or motivation can increase the cognitive resources devoted to a task. If relevant to schema acquisition and automation, such an increase also constitutes an increase in germane cognitive load. The cognitive load first guideline aims to maximize germane load by keeping a lean multimedia design, thereby reducing extraneous load. The key is to manage your multimedia for the amount of cognitive load on the user's working memory. Number 8. The 8th design guideline for multimedia is called the SSF model, or the Structured Sound Function Model. The SSF model recommends applying sound to help users to control their attention to the visual events in the multimedia. The prescription is 5 functions and 3 structures in the SSF model that, when combined, can help users to focus their attention on important visual events in the multimedia. For best results, the SSF model should be used with a strong domain or curricular focus and delayed post-tests to assess long-term learning effects. As a job aid or method of designing multimedia instruction, research with the SSF mode should also consider the environmental content and learner factors that will also be, to some degree, affect user learning and performance. So let's have a look now at a slide here on design guidelines. Once again, just to review, we can see number 1, let's say whatever works. Design by type is number 2. Favorite method is number 3. Favorite feature is number 4. Balance the input is number 5. The maximum impact is number 6. Cognitive load first, and followed finally by the structured sound functions model or design guideline. Now let's go back and look at the opposite side of the same coin, or as Mayer says, the other side of the same street. That is to say, we've had multimedia learning, we've been talking about that. Now we're going to talk about the learning part of the design. They've got design on one side, now we're going to look at how learning is. Well, learning is, if you think about learning as a cause, as a result of a cause, so the design was the cause or the antecedent, then the learning is the result, outcome we like to call it in education, outcome, or consequence, as psychologists prefer to call it, a consequence of learning. Okay, it may not be a direct result or outcome. So let's look at these 8 guidelines, but now from the perspective of learning. Number 1 would be the intuition of the web designer. Number 2 would be a good software taxonomy. You pick up a good taxonomy and you say, I'll run with that. Number 3, you might say proper selection of different media. Now this was very popular in the 70s and 80s. Reiser and Gagne used to consider selecting technologies as a very important part of instructional design. Proper methods of instruction, proper methods, rather than the proper technologies, the proper methods. So as we mentioned before, learning is simply getting the right teaching method. And Clark and Gabrielle Solomon, a number of people are involved with this view. Logogens and imagens is number 5. Some language in your design, some graphics, and definitely you'll get some result. This is Richard Mayer's view, that if you simply add some graphics and some narration, you'll get a good result on learning. Number 6, separate auditory and visual memories. This is Alan Baddeley in the UK, and his view, particularly with young children, because they have no phonological loop, that getting young children to look at visual materials to get them to subvocalize, that is, to simply talk to themselves, and now often we'll do that when we encounter some difficult text, for example, and you get a dry throat, and you don't realize it because you are trying to create another P code that will improve our working attention and our working memory. And by the way, this particular number 6, Alan Baddeley in the UK, his model is called working memory, a working memory model, a triarchic working memory model. But Ian Neath right here at MUN has said it's much more like a working attention model. And I tend to think it's true because it does work with sensations coming in. So designing instruction that includes some auditory and some visual, as opposed to some language, which is sound or text and graphics, okay? So auditory and visual will have an impact on learning, according to this particular guideline. Reducing extraneous information, that's cognitive load theory, isn't it? So simply if you reduce all the extra stuff that's in your multimedia design, in your website or whatever, you remove all that, the cosmetic sounds and things that run across the screen or whatever, that will simply improve the probability of learning. And finally, number 8, students controlling their own attention. And that's where we're going to go with another clip, is we're going to look at this number 8 in more detail. Students controlling their own attention. So what does that mean? Well, if multimedia is designed in such a way that it focuses on the amount of auditory stimulus that's coming in related to the visual events that are already prescribed, then students will be able to control attention and thereby learn better. Okay, now if we put these two together, let's put these two together, we can see how in this slide, if learning is caused by let's go right back up to number 1 again, the developer's intuition, then your design guideline will be whatever works. If you believe that multimedia learning from a multimedia is caused by, or certainly as a consequence of, choosing a proper taxonomy in the early 1980s, there was a tutor tool 2T taxonomy. In the 1980s, that was changed to the one that's probably more familiar to us now, which is tutorial, drill, simulation, game. So that was 4, right? And in the late 80s, there was another one called learning environments. So now we're probably more familiar with this term learning environments, which can be a combination of these things. But whichever you choose, you are categorizing the software you make or the website you design by whether it's a drill, whether it's a taxonomy, whether it's a, you see what I mean? So taxonomy is an important part. And if you ascribe to taxonomies, then you are designing by type, by a type tutorial. I'm going to design a tutorial. I'm going to design a game. I'm going to design a simulation, okay? Number 3, technology selection. This is the old view. Reiser particularly, who suggested that in your instructional design, somewhere you've got to select, like you're taking things off a shelf, groceries off a shelf, you're looking at, and you'll select some, maybe a podcast as a device to use because it happens to be most popular this year, or maybe it's voice over internet protocol, Illuminate Life or something like that, or maybe it's some mobile, so now we're talking about M-learning, okay, devices that students can carry around. So we'll program something for that. Okay, if you ascribe to that technology selection, then you're looking at, favorite method, favorite feature actually. It looks like this diagram is a little bit mixed up, but not to worry, we're still looking at the same method of teaching, favorite method. Favorite of technology selection, its favorite feature. Let's go to number 5, imagens and logogens. Imagens and logogens, again, are looking at spatial, graphics, white space even. That is the absence of anything there. And if something is small on the page, it helps to focus attention. And some kind of language. If you speak French, tu parles en français, you must know a lot about the language in order to make referential connections with the visuals. Okay? So it's important that students will understand that in their target audience, or the instructional designers will be aware, designers will be aware of that. If you ascribe that there has to be a balance of imagens and logogens, you ascribe to balanced input. Number 6 is auditory visual. Again, balancing, but this time simply with sound and visual events. Now, the point of putting together sound and visuals is to make the most of your multimedia design in order to create a maximum impact in the guideline. Okay. Number 7, intrinsic, extrinsic, and germane load. Again, this is what we've already talked about in this clip. Then you're going to be designing for cognitive load. Okay, and evidence is good that reducing cognitive load can have an impact on learning, on what's learned and how much is learned. Okay, and the last one that is controlling attention. Not us controlling attention as designers, but helping the student to control their attention. We used to call this extrinsic motivators, right? And intrinsic motivators. But it's not about motivation. It's about working attention. So it's very much like, what is it, auditory visual memory, where we looked at the different memories and say, well, we have to make sure we attend to those. Auditory memory, visual memory. But it's more sophisticated than that. We create episodes and we compare them with long-term memory. Okay, so we're going to talk about that in our next clip, which is the structured sound functions model, in order to help students to control their attention.